Good morning, my dear students. My name is Manish, and you are watching your favorite YouTube channel, that is Manish Physics. So, children, today we are going to study a very important chapter of class 9 physics ICSC. Okay, the chapter number 4. What is that chapter is? प्रेशर इन फ्लूइड एंड एटमॉस्फेरिक प्रेशर। ओके बच्चों, इस चैप्टर में बहुत ही ज्यादा कॉन्सेप्ट है, राइट। प्रेशर के बारे में और समझने लायक बहुत चीजें हैं बच्चों, राइट। ठीक है, तो जैसा मैं कहता हूं बच्चों, क्या बिल्ड इट राइट, बिल्ड इट वंस, राइट बच्चों। कहने का मतलब है कि तुम्हारा इन्वॉल्वमेंट जरूरी है। जब तुम इन्वॉल्व रहोगे तो तुम्हारा ग्रोथ होगा। हाँ, तो अपना कॉपी निकालो, पेन निकालो, नोट्स बनाओ। आओ शुरू करते हैं बच्चों चैप्टर नंबर 4, है ना। ये प्रेशर का सीरीज है बच्चों, ठीक है। चैप्टर नंबर 4 क्या है? प्रेशर इन फ्लूइड, ओके, एंड एटमॉस्फेरिक प्रेशर। ठीक है बच्चों, प्रेशर इन फ्लूइड एंड एटमॉस्फेरिक प्रेशर। ठीक है बच्चों, टॉपिक 2 चलो शुरू करते हैं प्रेशर के बारे में। बहुत ही इंपॉर्टेंट चैप्टर है बच्चों, राइट। आओ बच्चों शुरू करते हैं, ठीक है। तो पहला चीज है बच्चों, व्हाट डू यू मीन बाय थ्रस्ट एंड प्रेशर? तो लिखो बच्चों, हाँ, पहला थ्रस्ट, THRUST, थ्रस्ट एंड प्रेशर। ओके बच्चों, ठीक है। तो बच्चों देखो, थ्रस्ट किसे किसे बोलते हैं बच्चों? कोई भी एक एरिया लो, ठीक है। मान लो मैंने ये एरिया ले रखा है, ध्यान देकर सुनो, है ना। ये मान लो ABCD एरिया है, ठीक है। अब बच्चों इस पर मैंने फोर्स लगानी है, ठीक है, राइट। तो फोर्स तो मैं यूं लगा सकता हूं, बोलो हाँ या नहीं, ठीक है। फोर्स तो मैं यूं ऐसे भी लगा सकता हूं, बोलो हाँ या नहीं, ठीक है। किसी भी एक पॉइंट पे मैं बात कर रहा हूं, ठीक है। लेकिन जो फोर्स इस पे परपेंडिकुलर लगे, ठीक है बच्चों, उस फोर्स को हम क्या बोलेंगे? थ्रस्ट बोलेंगे। जैसे कि मैं तुम्हें समझाता हूं बच्चों, ध्यान देके सुनो, ठीक है। देखो मैंने क्या कहा बच्चों, मान लो कि जस्ट एक लाइन है ना, तुमने यूं ऐसे इस पॉइंट पे तुमने प्रेशर लगाया, ठीक है बच्चों। तो ये प्रेशर इस वाले एरिया पे कैसे लगा? परपेंडिकुलर। तो ये क्या कहलाएगा? ये कहलाएगा थ्रस्ट, ठीक है। लेकिन बच्चों वैसे ही मैंने कहा कि इस पॉइंट पे मान लो मैंने यूं ऐसे एक एंगल, थीटा एंगल पे मैंने फोर्स लगाया है, ठीक है बच्चों। तो ये जो फोर्स है ये थ्रस्ट नहीं कहलाएगा बच्चों, ठीक है। ये फोर्स तो कहलाएगा, लेकिन थ्रस्ट हम उसी को बोलेंगे जो किसी भी एक पॉइंट पे या एरिया पे कैसे लग रहा हो बच्चों? परपेंडिकुलर लग रहा हो। समझ में आया? तो ये जो 90 डिग्री वाला जो फोर्स है ये तो थ्रस्ट कहलाएगा। लेकिन ये मान लो F1, ये F2, हाँ, तो F1 तो कहलाएगा थ्रस्ट, लेकिन F2 थ्रस्ट कहलाएगा नहीं। मैं दोबारा बोल रहा हूं कि वो फोर्स जो परपेंडिकुलरली लगे, दैट इज ओनली थ्रस्ट। समझ में आया बच्चों? सो थ्रस्ट इज नथिंग बट द फोर्स एक्टिंग परपेंडिकुलरली। देखो बच्चों, क्या है? थ्रस्ट इज नथिंग बट द फोर्स एक्टिंग ऑन एनी एरिया परपेंडिकुलरली। समझ में आया बच्चों? ठीक है, थ्रस्ट इज नथिंग बट द फोर्स एक्टिंग ऑन एनी एरिया परपेंडिकुलरली। ठीक है बच्चों, राइट। सो दिस इज व्हाट द थ्रस्ट। तो बच्चों चूंकि थ्रस्ट तो फोर्स ही है, तो इसका यूनिट अगर हम बोले बच्चों क्या होगा, तो इसका यूनिट इज सिमिलर टू द यूनिट ऑफ फोर्स। तो मैंने कहा SI यूनिट क्या होगा बच्चों इसका? तो होगा न्यूटन, राइट। लिखते कैसे हैं तुम्हें पता है बच्चों, N। CGS क्या होगा बच्चों? दैट इज डाइन। और हमने ये पढ़ रखा है 1 न्यूटन बराबर 10⁵ डाइन। बोलो हाँ है ना बच्चों, तुमको पता है ना बच्चों? अच्छा, मैं दोबारा बता देता हूं बच्चों। देखो मुझे पता है F = ma, राइट। कौन सा लॉ है? सेकंड लॉ ऑफ मोशन, ठीक है। तो m क्या है बच्चों? kg मीटर पर सेकंड स्क्वायर। तो ये हो गया SI यूनिट, जिसको हमने कहा न्यूटन, ठीक है। अगर हम आएंगे बच्चों CGS में, तो क्या कहेंगे बच्चों? ये क्या हो जाएगा? kg हो जाएगा, यहाँ पर हो जाएगा ग्राम, और मीटर हो जाएगा सेंटीमीटर पर सेकंड स्क्वायर, ठीक है। अब आओ इसको हम बच्चों कन्वर्ट करते हैं CGS में, ठीक है, जिसको हम न्यूटन बोलते हैं, और इसको हम क्या कहते हैं? डाइन कहते हैं, ठीक है। तो ध्यान दो बच्चों, kg कितना है बच्चों? 1000 ग्राम होता है, 10⁻³ ग्राम। मीटर कितना होता है? 10 स्क्वायर सेंटीमीटर, और 1 सेकेंड तो वैसे ही रहता है सेकंड स्क्वायर, ठीक है। तो ये कितना हो जाएगा बच्चों? 10⁻³ इंटू 10 स्क्वायर हो जाएगा 10⁵ ग्राम सेंटीमीटर पर सेकंड स्क्वायर, ठीक है बच्चों। समझ में आया बच्चों? 10⁵ ग्राम सेंटीमीटर पर सेकंड स्क्वायर। तो भाई साहब ग्राम सेंटीमीटर पर सेकंड स्क्वायर क्या कहते हैं? डाइन कहते हैं। तो विच इज इक्वल टू डाइन, ठीक है। तो विच इज इक्वल टू हाउ मच? 10⁵ डाइन। तो बच्चों 1 न्यूटन बराबर कितना आया? 10⁵ डाइन आया। ठीक है बच्चों, ये हमें याद रखना है। ठीक है, तो ये एसआई यूनिट और सीजीएस हुआ। अगर मैं बोलूं कि भाई व्हाट इज द ग्रेविटेशनल यूनिट, तो ये भी बहुत आसान है बच्चों। क्या होगा, देखो एफ बराबर क्या होता है बच्चों, एम इंटू ए होता है। अगर ए बन जाएगा जी, तो क्या बन जाएगा बच्चों, एम इंटू जी। ये भी फोर्स है, राइट, जिसको हम कहते हैं वेट। राइट, ग्रेविटेशनल में हमने इसकी चर्चा करी थी। ठीक है बच्चों, तो अगर मान लो मैंने मास को 1 kg ले लिया, ठीक है, 1 kg, और ये मैंने जी को यूं ही मल्टीप्लाई कर दिया, दैट इज 1 किलोग्राम फोर्स। ठीक है बच्चों, और हमें पता है 1 किलोग्राम फोर्स कितना न्यूटन बच्चों, सो 1 किलोग्राम फोर्स इक्वल टू 9.8 न्यूटन। समझ में आया बच्चों, तुम जी का वैल्यू पुट कर दोगे तो क्या बन जाएगा, ये देखो, मान लो मैंने निकाला F इक्वल टू एम इंटू जी, एम हो गया 1 kg, और जी कितना, जी का वैल्यू तुम पुट कर देते हो तो 9.8 मीटर पर सेकंड स्क्वायर। तो बच्चों केजी मीटर पर सेकंड स्क्वायर क्या होता है, न्यूटन। तो दैट इक्वल कितना हो जाएगा, 9.8 न्यूटन। तो 1 किलोग्राम फोर्स इक्वल टू 9.8 न्यूटन। सिमिलरली बच्चों हम निकाल देंगे 1 ग्राम फोर्स। तो बच्चों ध्यान देकर देखो, 1 किलोग्राम फोर्स बराबर 9.8 न्यूटन। बोलो हाँ या नहीं बच्चों, 9.8 न्यूटन। तो 1 किलोग्राम फोर्स कितना बच्चों, 10⁻³ ग्राम फोर्स। किलो का मतलब क्या होता है, 1000। दैट इक्वल टू 9.8, 1 न्यूटन कितना बच्चों, 10⁵ डाइन हो जाएगा। ठीक है, तो ये 10 को यहाँ पर 10 स्क्वायर में कट जाएगा, तो 1 ग्राम फोर्स कितना हो जाएगा, 9.8 इंटू 100 डाइन, और दैट इक्वल टू 980 डाइन। ठीक है बच्चों, तो 1 ग्राम फोर्स कितना आ गया, 980 डाइन आया। समझ में आया बच्चों, राइट, वेरी इंपॉर्टेंट। ठीक है, तो ये सब हमने यूनिट पे बात करी। ठीक है बच्चों, थ्रस्ट के, राइट बच्चों, हाँ या नहीं, बोलो हाँ या नहीं बच्चों, राइट, वेरी गुड। ओके, अब ध्यान देकर सुनो बच्चों, मैंने क्या कहा बच्चों, थ्रस्ट लिखो, लिखो थ्रस्ट इज अ वेक्टर क्वांटिटी, बिकॉज ये फोर्स है, और फोर्स स्केलर का होता है कि वेक्टर बच्चों, वेक्टर होता है। तो फोर्स क्या होगा, आई मीन टू से, लिखो थ्रस्ट, ओके, इज अ वेक्टर क्वांटिटी। ठीक है, कभी कभी सवाल आया था बच्चों, थ्रस्ट क्या है, स्केलर है कि वेक्टर क्वांटिटी है। ठीक है, राइट बच्चों, ठीक है, तो ये था थ्रस्ट के बारे में, हमें जो जानना था हमने जाना। ठीक है, अब आओ बात करते हैं बच्चों, व्हाट इज प्रेशर, व्हाट इज प्रेशर। ठीक है बच्चों, तो जब मैंने प्रेशर के बारे में कहा बच्चों, तो प्रेशर क्या होता है, दैट इज नथिंग बट थ्रस्ट एक्टिंग पर एरिया। ओके, थ्रस्ट एक्टिंग पर एरिया। तो बच्चों थ्रस्ट बेसिकली होता क्या, फोर्स ही होता है, लेकिन कौन सा फोर्स होता है बच्चों, परपेंडिकुलर फोर्स होता है बाय एरिया। ठीक है बच्चों, याद रखना बच्चों, थ्रस्ट क्या है, थ्रस्ट जो है फोर्स है, राइट, विच इज वेक्टर क्वांटिटी। एरिया क्या है बच्चों, एरिया इज अ वेक्टर क्वांटिटी। लेकिन प्रेशर क्या है बच्चों, दैट इज स्केलर क्वांटिटी। ठीक है बच्चों, तो ये देखो, ये क्या हो जाएगा, इसका अगर मैं बोलूं एसआई यूनिट क्या होगा बच्चों, क्या होगा, दैट इज न्यूटन पर मीटर स्क्वायर। इसे क्या कहते हैं हम, पास्कल। ठीक है, सीजीएस क्या होगा बच्चों, सीजीएस यूनिट क्या होगा इसका, दैट इज डाइन पर सेंटीमीटर स्क्वायर। इसे हम यूं ही डाइन पर सेंटीमीटर स्क्वायर ही रखते हैं। ठीक है, तो ये है एसआई यूनिट, ये है सीजीएस यूनिट। और प्रेशर क्या है बच्चों, एक क्या है, दैट इज स्केलर क्वांटिटी है। जैसे मैंने पहले एग्जांपल लेके बताया बच्चों, क्या है, देखो यहाँ पर मैंने इस पॉइंट पे ऐसे थ्रस्ट लगाया, ठीक है, ये थ्रस्ट लगाया, तो ये थ्रस्ट लगा परपेंडिकुलरली इस वाले एरिया पे। ठीक है, तो क्या कहलाएगा, प्रेशर को थ्रस्ट पर एरिया कहलाएगा। लेकिन अगर तुमने प्रेशर ऐसे लगाया, ठीक है बच्चों, इंक्लाइन प्रेशर लगाया, ठीक है, तो मान लो ये, सॉरी, फोर्स लगाया, थ्रस्ट लगाया, आई मीन से फोर्स लगाया। ठीक है, तो ये फोर्स मान लो किसी एक एंगल पे आ रहा है, मान लो थीटा एंगल पे आ रहा है। ठीक है, राइट, तो अब जब थीटा एंगल पे बन रहा है, या फिर मान लो ये एंगल बच्चों, सॉरी ये एंगल है ना, ये एंगल थीटा है। ठीक है, तो हमें क्या करना पड़ेगा, हमें फोर्स के यहाँ पर कॉम्पोनेंट बनाने पड़ेंगे। ठीक है बच्चों, इसका मतलब क्या है बच्चों, तुम हायर क्लास में पढ़ोगे। ठीक है बच्चों, तुम लोगों ने पढ़ा है ना बच्चों, देखो मैं तुम्हें बताता हूँ, तुमने पाइथागोरस थ्योरम पढ़ा है, बोलो हाँ यानी, ये हो गया परपेंडिकुलर, ये बेस, ये है हाइपोटेन्यूस, ये हो गया एंगल थीटा। राइट बच्चों, तो अगर मैं तुमसे पूछूं व्हाट इज कॉस थीटा बच्चों, तुम क्या बोलोगे, कॉस थीटा इज इक्वल टू बी बाई एच। व्हाट इज साइन थीटा, इक्वल टू पी बाई एच, परपेंडिकुलर बाई हाइपोटेन्यूस, बेस बाई हाइपोटेन्यूस। तो ध्यान देकर सुनो बच्चों, कि अगर मैं यहाँ से बी निकाल दूं, तो बी क्या हो जाएगा, एच कॉस थीटा। बोलो हाँ यानी, तो मान लो ये एच है, मेकिंग एन एंगल थीटा, मुझे इसको बी की तरफ में लाना है, तो क्या करना पड़ेगा बच्चों, एच कॉस थीटा, मतलब ये जो लेंथ है उसका कोसाइन हो जाएगा बी में। तो इसका मतलब क्या है, जो साइड एंगल को टच कर रहा है उसको हम कोसाइन ले लेंगे। ठीक है, और अगर मान लो मुझे इसी को पी की तरफ ड्रॉ करना हुआ, तो क्या हो जाएगा, पी क्या हो जाएगा बच्चों, एच साइन थीटा। ठीक है, तो जो साइड टच कर रहा है किसको, एंगल को वो हो जाएगा कोसाइन, उसके साथ मल्टीप्लाई कर दो, जैसे यहाँ हो गया P इक्वल टू एच कॉस थीटा, ठीक है। और जो एंगल को टच नहीं कर रहा हो जाएगा साइन थीटा। तो ध्यान दो ये वाला क्या, इसका मुझे कॉम्पोनेंट बनाना है परपेंडिकुलर, तो इसको मैं इधर लेकर के आऊंगा। तो कौन है ये, 4 से F है ना। कितना एंगल बनाएगा, थीटा, मुझे लाना है किसमें, वर्टिकली में, ठीक है, राइट, परपेंडिकुलर में, तो बन जाएगा F कॉस थीटा, ये हो जाएगा थ्रस्ट। समझ में आया कि नहीं बच्चों। तो ये जो परपेंडिकुलर फोर्स है ये हो जाएगा थ्रस्ट, बाई हम निकाल देंगे एरिया, तो हमको मिल जाएगा प्रेशर। समझ में आया कि नहीं आया बच्चों, समझ में आया कि नहीं आया। तो फोर्स इज अ स्केलर क्वांटिटी, नॉट द वेक्टर क्वांटिटी, ठीक है, राइट। अब बच्चे आगे बढ़ते हैं, ठीक है, राइट, वेरी इंपॉर्टेंट। तो बच्चों हमने प्रेशर के डिस्कस करे क्या, व्हाट डू यू मीन बाय प्रेशर, व्हाट डू यू मीन बाय थ्रस्ट, थ्रस्ट के बारे में बात करा हम लोगों ने, ठीक है। अब हम प्रेशर के डिफरेंट यूनिट्स के बारे में बात करेंगे बच्चों। क्या कहा मैंने, डिफरेंट यूनिट्स। हमने प्रेशर के 2 ही यूनिट्स पढ़े, एक पढ़े एसआई यूनिट जिसको हमने कहा पास्कल, ऑन द नेम ऑफ द साइंटिस्ट दैट इज मिस्टर पास्कल, राइट, एंड अनदर इज व्हाट द सीजीएस, दैट इज डाइन पर सेंटीमीटर स्क्वायर। नाउ चिल्ड्रन, if I'll ask you convert the SI unit into CGS unit, right, दोनों में रिलेशन निकालो बच्चों। तो 1 SI क्या है बच्चों, 1 पास्कल इक्वल टू 1 न्यूटन पर मीटर स्क्वायर। तो 1 न्यूटन कितना बच्चों, 10 टू द पावर 5 डाइन, राइट। 1 मीटर स्क्वायर कितना, 10 टू द पावर 2 सेंटीमीटर का स्क्वायर। तो कितना हो जाएगा, 10 टू द पावर 5 डाइन होल डिवाइड बाय 10 टू द पावर 4 सेंटीमीटर स्क्वायर। तो ये कितना हो जाएगा बच्चों, दैट इज 10 डाइन पर सेंटीमीटर स्क्वायर विच इज इक्वल टू 1 न्यूटन पर मीटर स्क्वायर, ठीक है बच्चों। तो ये एसआई और सीजीएस में क्या हो गया, कन्वर्शन हो गया, ठीक है बच्चों, राइट। तो अगर मैं तुमसे पूछूं, चलो बच्चों डिफाइन करो 1 पास्कल क्या होगा, व्हाट इज 1 पास्कल, ठीक है बच्चों। तो अगर मैंने कहा कि फोर्स इक्वल टू थ्रस्ट पर क्या बच्चों, थ्रस्ट पर एरिया, ठीक है। तो 1 पास्कल इज नथिंग बट 1 न्यूटन पर 1 मीटर स्क्वायर। मतलब what is 1 Pascal is nothing but the pressure exerted by the body when the body is applying the thrust of 1 Newton on 1 meter square area, right children, so that is what the 1 Pascal, ठीक है बच्चों। तो SI और CGS के अलावा अगर मैं कोई बोलूं यूनिट बच्चों तो क्या है बच्चों, that is बार, ठीक है बच्चों। तो what is 1 बार, बार भी एक यूनिट है बच्चों प्रेशर को मेजर करने के लिए, ठीक है। तो 1 बार कितना होता है बच्चों, 1 बार इज इक्वल टू 10 टू द पावर 5 पास्कल, ओके, 10 टू पावर 5 न्यूटन पर मीटर स्क्वायर, और आई कैन से 10 टू पावर 5 पास्कल, ठीक है, 1 बार, ठीक है बच्चों। तो मैंने कहा व्हाट नेक्स्ट हुआ 1 मिली बार, ठीक है बच्चों, क्या हो जाएगा, सो 1 मिली मतलब क्या, 10 टू पावर -3, और बार मतलब क्या, 10 टू पावर 5 न्यूटन पर मीटर स्क्वायर, सो दैट इक्वल टू 10 स्क्वायर न्यूटन पर मीटर स्क्वायर, और आई कैन से 100 न्यूटन पर मीटर स्क्वायर इज 1 व्हाट, मिली बार, ठीक है बच्चों। तो हमने क्या पढ़ा, एसआई पढ़ा पास्कल, डाइन पर सेंटीमीटर स्क्वायर पढ़ा, बार मिली बार पढ़ा, ठीक है। अब बच्चों हम मेजर करेंगे एटमॉस्फेरिक प्रेशर, ठीक है बच्चों। क्या है एटमॉस्फेरिक प्रेशर बच्चों, देखो एटमॉस्फेरिक प्रेशर को हम लिखेंगे स्मॉल p ATM। ATM मतलब बच्चों ऑल टाइम मनी नहीं, राइट, या ऑटोमेटिक ट्रांजैक्शन मशीन भी नहीं। ATM का मतलब क्या है बच्चों, दैट इज एटमॉस्फेरिक प्रेशर, ठीक है। हमारे सर पे एक एटमॉस्फेयर का प्रेशर पड़ रहा है, लेकिन हम हैबिचुएटेड है, इसलिए इस प्रेशर को हम आराम से झेल जाते हैं, ठीक है बच्चों। तो एटमॉस्फेरिक प्रेशर को हम कैसे मेजर करते हैं बच्चों, ध्यान देकर सुनो बच्चों। मान लो ये एक बीकर है, ठीक है, तुमने क्या किया, एक मतलब एक टेस्ट ट्यूब लिया, ठीक है। जो टेस्ट ट्यूब का 1 एंड क्या है बच्चों, क्या है, ओपन है, ठीक है। माने टेक अ टेस्ट ट्यूब, ओके, हुज 1 एंड इज ओपन, क्लीन इट, ड्राई इट, ओके, इज दैट क्लियर। एंड इस टेस्ट ट्यूब में क्या बने हुए होंगे बच्चों, स्केल बने हुए होंगे। समझ में आया बच्चों, क्या बने हुए होंगे, स्केल बने हुए होंगे, इज दैट क्लियर बच्चों, स्केल बना हुआ है, ठीक है। अब तुमने क्या किया, जस्ट क्लोज द ओपन एंड ऑफ द what children, that is the test tube and invert it, है ना, and put inside this beaker, ठीक है। इसमें क्या डाल दोगे, पहले पहले बच्चों इसमें मर्क्यूरी डाल दोगे, ड्राई मर्क्यूरी डाल दोगे, ठीक है। मर्क्यूरी डालने के बाद इसको क्या करोगे, ऐसे इन्वर्ट कर दोगे, ठीक है बच्चों। और यहाँ पर भी लिक्विड मर्क्यूरी है, ठीक है, इसके नीचे भी मर्क्यूरी है बच्चों, ठीक है। समझ में आया कि नहीं आया। तो जाहिर सी बात, जब तुमने इसको उल्टा करके इसमें डाल दिया, जस्ट व्हाट विल यू डू, just with the help of your thumb try to close the open end, invert it and place inside the beaker where the liquid mercury is placed. Now what happens, obviously ये mercury का scale है, right, so mercury पे क्या लगेगा, gravity लगेगा, और mercury धीरे धीरे नीचे आकर के एक particular जगह पे रुक जाएगा। उसके बाद वो फर्दर नीचे नहीं आएगा। मेरी बात तुमको समझ में आई या नहीं आई बच्चों? ठीक है, राइट। तो वो कहाँ आके रुक जाएगा बच्चों? वो आके रुक जाएगा 76 सेंटीमीटर पे। ठीक है, कौन रुकेगा बच्चों? मर्क्यूरी। उसका सिंबल क्या है? Hg। ठीक है बच्चों, कहाँ आके रुक गया? 76 सेंटीमीटर पे आके रुक गया। ठीक है, तो हम बोलेंगे इस पॉइंट पे जो प्रेशर हमने निकाला बच्चों, और मान लो यहाँ पर इस पॉइंट पे प्रेशर है ना, यहाँ पर जो प्रेशर निकाला, इट हैज बीन फाउंड दैट कि दोनों जगह पे जो प्रेशर लग रहा है वो सेम लग रहा है। ठीक है, तो यहाँ पर कौन सा प्रेशर है बच्चों? इस जगह पे एटमोस्फियर का प्रेशर है, इसीलिए हमने इसे भी क्या नाम दिया? एटमोस्फेरिक प्रेशर। ठीक है बच्चों, तो एटमोस्फेरिक मैं लिखूंगा, अगर मान लो PATM, so that is nothing but 76 centimeter of mercury column. Why we are calling it column? Because this is the vertical line, right? If instead of vertical line, if it would have been a horizontal line, then we might called it what? A 76 centimeter of the mercury row. Okay, since it is standing, that is why we are calling it as 76 centimeter of mercury column. Is that clear, children? Now what shall we do right now, children? You see, convert centimeter into meter. So children, we know that 100 centimeter equal to 1 meter, right? So what is 1 centimeter, children? That is 1 by 100 meter. So convert it. So 76 into 1 by 100 meter of same mercury column, right? So that is equal to 0.76 meter of mercury column, right? So if you write 76 centimeter of mercury column, which is equal to 0.76 meter of what? Mercury column, or that is equal to 760 millimeter of mercury column. All are the same, children, right? I have just converted the centimeter into meter, and then finally meter is to millimeter, right, children? Is this experiment you understood, right? This is how we calculate the what? Atmospheric pressure, right, children? Now come back to our units. Okay, so children, we can call PATM, that is nothing but 76 centimeter of Hg, I mean to say mercury column, or you can write 0.76 meter of mercury column, or you can write 760 millimeter of mercury column. This is how you measure what? The atmospheric pressure, and it has been found that 1 atm, okay, pressure, or 1 atmospheric pressure, that is nothing but 1.013 into 10 to the power 5 Newton per meter square. Okay, children, now this is nothing but 1.013 into 10 to the power 5 Pascal. 1 atmospheric pressure is that clear, children, right? So since this is nearly 1.0 something, children, so sometimes, or maximum times, or even if you take this is 10 to the power 5 Pascal, there will be nothing wrong. Is that clear, children? Right? So this is what the 1 atmospheric pressure is all about. Am I clear to everybody? Say yes or no. Okay, children, please write down in the comment box. Okay, children, so you will see, children, that 1 atmospheric pressure we have calculated. So now, children, let us find another unit, children. So one more unit is what? Same. In order to find the atmospheric pressure, we are using the torr. Okay, so 1 torr, okay, that is nothing but 1 mm of what, children? Mercury. Okay, 1 mm of mercury, same thing, children. Okay, so if I let us find out the relation between the torr and the atmospheric pressure, children. We know 1 atm is nothing but 760 mm of mercury column, right? So this is nothing but 760 into 1 mm of Hg column, right, children? Column, is that clear? So I will write 760, but what is 1 mm of mercury column? That is torr. I can write TORR. So 1 atmospheric pressure is nothing but 760 torr. Is that clear, children? Right? So these are the units, children. Okay, you should remember these units. These are very important, right? You might get 1 mark question, okay, depending upon the, you see, the question, right? Okay, children, is that clear? So this is all about the units. Okay, so let us discuss about the, children, factor affecting the pressure. Please write down factors. Okay, factors affecting the pressure. Okay, children, see, please don't excuse me for my, you see, handwriting, right? I can understand this is difficult to understand, but still, children, I am pronouncing it right. Factor affecting the pressure. Okay, so if you see children, pressure is equal to force per area, right? So pressure is inversely proportional to area. So children, if area increases implies pressure decreases, and if area decreases implies pressure increases. Okay, let us give me a very small, let us give a few example which based upon the area only. Okay, children, can you cut see brinjal with the help of your finger? Can you suppose can we cut brinjal or vegetables with the help of our finger? So answer is no. Right now, if you walk on the sand, and also camel also want walk on the sand, but camel is having no issue. What we when we are walking on the sand, we are facing problem. Our what feet will go deep inside the what that sand. Okay, why does this happen? Because camel leg has larger surface area, so pressure what the exerted is less, and since our leg is having smaller area, so pressure what we exerted on the sand will be more. That is why when you are standing on the sand, some portion of the leg is getting inside the sand, whereas when you are lying down on the sand, nothing happens. Why? Because the you see, when you are lying down, the area of contact of your body with the sand is increases, so pressure same weight exert less pressure as compared to when you are standing, because when you are standing, the area of contact of your leg is lesser. To say area is less. So when area is less, what about the pressure? That is very high. Is that clear, children? So in this two way, or you might have seen, see, when you are doing your gardening, right, you have a pipe, you just open the what tap, and then when the water is flowing inside the pipe, and suppose you want that the water should travel the longer distance, so what generally we do, children? We generally press, okay, some portion of the pipe, right, so that the area decreases. So when area decreases, pressure increases, and water can travel to a longer distance. Is that clear, children? Right, so in this manner you can able to convert the area. I meant to say what, children? If area is less, pressure is high. Pressure is high, area is less. Is that clear, children? Is that clear? Now let me give you one example, children. Let us give you one example. Children, just imagine, let me show you one example. Children, see, let me see, this is what, children, this is nothing but a cuboid, right, children? This is what a cuboid. Okay, I'm not advertising any company name, right? This is just an example I'm giving to you. Okay, children, see, now if I place in this manner, let us assume this one is what, for example, length. Okay, this one is breadth, and this one is height. Is that clear, children? If I say, assume this one is length, right, this one is breadth, and this one is height, this longer distance is height. So if I place in this manner, right, I place in this manner on my hand. Okay, so its weight is same. So you can see, children, what is the area which is contacting on my palm, children? So this is the base area, right? Base area, this length multiply with this length, obviously it is larger. Is that clear? So let us assume the pressure it develop is P1, right? Now when I keep the area, the same body on this manner, okay, so now this is the what area of contact which is contacting on my palm. Is that clear? So what is the area? This length multiply with this length. Is that clear? Say yes or no. So in second case, area decreases, so the body weight is same, but it applies more pressure, it exert more pressure as compared to the previous one. Why? Because when you are lying down this in this manner, so area is what? Area is increases, area of contact is this one, which will is higher as compared to when you just make it a vertical line in this manner, right, children? Vertically. Okay, so you find the area decreases, the contact area decreases, and when area decreases, force, children, what will happen? Force in not force, sorry, pressure increases. Is that clear, children? Right, is that clear? So this is how you see, you might get some question, length, breadth, that height is given. The question is, if you place the area on this manner or on other manner, right? I mean to say, if you place the area in this manner or you place the area in this manner, weight will be given to you. Calculate the ratio of pressure in both the cases, right? Simply find out the area. You know how to find the area, length into breadth. Find out the area, weight is given to you, weight by area, the pressure will be generated. Find out or compare in both the cases, right, children? Right, so this is how the factor on which the what pressure depends. So children, we discuss about the pressure, right? So P equal to what, children? I can say P is equal to force per area, and this force is what, children? Remember, this is not simple force. This is the force which is acting perpendicular, and that force name is what? Thrust. We already have discussed earlier, right, children? So you can see, children, here this is force is thrust. This is area, right? So pressure also depends upon what, children? The force, or I can say thrust. So larger the thrust. See, for example, let me give you two situation. Okay, children, see, as already we know that pressure is equal to force per area. So pressure directly to force and inversely to area. This is how it depends upon, right, children? So let me assume there is a body here. Okay, I mean, this is the surface, right? On this surface I place a body whose mass is, let us assume, 10 kg, right? And let us, this is the area. Okay, so this area, let us this is 5, this is 5. Okay, so 5 5 ja 25 meters square. For example, centimeter square I can take, not meter square. Basically this is 5 centimeter, this is also 5 centimeter square, okay, in size. So I can say, children, what that is, 25 centimeter square. Okay, is that clear? Right now, children, if the same area, okay, area same, children, area of contact I remain the same. Let this is 25 centimeter square, but I increase the mass. Okay, so mass will be, for example, 20 kg right now. Okay, children, so this is the case number one, this is case number two, right? So what is the pressure it generates, children? Let me take pressure P1 is equal to what? 10 kg. Convert it to gram, children. So 10 into 10 to the power 3 gram per 25 centimeter square. Right, children? Clear? So you will see this is 100 into 100. Okay, gram per centimeter square, whole divided by 25. 25 4 ja, that will be 400 gram per centimeter square. That is the pressure P1 generated, right? In the similar manner, let us find out the P2. Let this case is 2. So P2, the see, children, here the area is the same, but what about the weight is higher. So now pressure equal to force per area. Force is 20 into 10 to the power 3 gram per 25 centimeter square. Right, children? So you will see, children, same thing. That is, you see 200 into 10 square, I can say. 110 you multiply here, gram per centimeter square by 25. 25 8 ja. This is 800 gram per centimeter square, P2. So see, children, I place area same. Okay, what I mean to say, we have taken same area, but in the same area, children, you find ki I change the weight. I just change the weight twice. I mean to say, I change the mass twice. Here the 10 kg, here 20 kg. So you can say pressure also increases, right, children? In case one, pressure was 400 gram per centimeter square. Right now the pressure is 800 gram per centimeter square. Is that clear, children? Is that clear? Right, children? So this is the case number one, where the pressure depends upon the what? Weight of the body, right? Now let me find the pressure depends upon the area. Okay, so children, what happens? See, I take the weight of the body same, right? So let us assume, children, let us assume one cuboid. Cuboid you can take, or you can take cube. Let us take cuboid, right, children? Let us, I have taken a cuboid, right, children? In this manner I place it, right? This is what the, this is what I place it, right? Let the area remain the same in both the cases, children, right? So what will be the area? Let this is, I can say, this is 5, this is 6, and this is 7. See this one, huh? This one is 5, this one is 6, okay, and this one is 7. Which one is 7, children? See, this one. This is how you explain better. I mean, you will learn, right? This vertical is 5, this horizontal is 6, and this one I can say 4. For example, this one is 4, right? Clear, children? Right? So if I place in this manner, what is the area here, children? I will not see, we will have to calculate the area. Let us find out the weight remains same, right? So here let the weight is W, okay, and here what is the area, children? 6 4 ja 24 centimeter square. Let this is 6 centimeter, this is 6 centimeter, right, children? Right? But if I place just vertically up, right? So if I place, children, just vertically up, so this is the area which will be contacted. Yes or no? So this is 4 and this one is 5. So area becomes what, children? 5 4 ja 20 centimeter square. Children, just do it vertically. Is that clear, children? Just see in this manner. See, I'm a little bit poor in drawing the diagram. That is why, you see, try to avoid it. See, children, now I think it will be clear, children, right? Clear? Okay, somewhere. Acha. Okay. So children, this is 4 and 5. So let this is 4, 5. This one is 4, right? So the area is 5 4 ja 20 centimeters square. Weight remain the same, children, right? So what is the pressure it develop? P1 is equal to weight by 24 centimeters square, whereas P2 is equal to what, children? Weight by 20 centimeters square. So tell me, children, in which case area is smaller? So area is smaller in this case. I can say case number 2. This is case number 1. This one is case number 2. So you will find the area of case 2 will be greater than the area. Sorry, area of case 2 will be lesser than the area of case 1, right? So if area larger, pressure is lower. Here pressure is larger. So I can say here P2 is greater than P1. Is that clear? So if smaller the area, larger is the pressure. Larger the area, smaller is the pressure. That is why here this will be the relation. Is that clear, children? How the factor I mean, what are the factor on which the pressure depends? Okay, children. Now let us take, okay, children, let us take the weight remains constant. Let us develop the pressure. I mean, let us assume, let us talk about the pressure, how we can increase and decrease it just without changing the weight, okay, or applying force, or I can say thrust. Okay, so children, please write way to increase or decrease the pressure. Okay, children, way to increase or decrease pressure. So children, the best way I can say, let us talk about the area only. Why? Because if you apply the larger force, okay, I can understand, but even if the area is larger, the larger force will not be generate that amount of pressure. Is that clear? Let us take the example of, I mean to say, the camel. Okay, since it has larger surface area of its leg, right? So even though it has large weight, right, obviously the camel is of larger weight than we people, right? Is that clear, children? But we generate more pressure on sand rather than the elephant, or I can say what, that is I mean the camel, right? So that is why let us not talk, I mean, let us not focus on the weight, rather let us focus on the surface area, right, children? So if I give you one example, children, see, let me give one example to what, demonstrate. Let, children, this is any screw, right? This is a screw, children, right? This is the screw, and let this one is the nail. This is the screw, and this one is the nail. Just, children, see, this is the contact area, this is the this one is the contact. Let, this is A1, this one is A2. Which one is larger? Obviously A1 is very greater than A2. That is why when you are hammering it, right, on the screw, just take a screw and hammer it on the wall, you will find, even though if you apply the same force, let here the force F1, here the force F2, and both are equal, so F1 is equal to F2 equal to F. So even though you apply the same force on the body, children, is that clear, right? Same force you are applying on the on both what, the screw and nail, but it generates very less pressure. That is why screw, while hammering it on the wall, it will not get inside the wall, whereas the nail, when you apply the hammering, when you hammer it, or I mean to say when you apply the force, okay, since its area is very less, so pressure it generates is very large, and that is why it will go very easily inside the wall. Am I clear to all of you? Say yes or no, children. If you are understanding, please write that yes sir, we are understanding in the comment box. And even if you have a difficulty, trust me, I'll explain your difficulty one more time. Is that clear, children? Right? So this is why, this is how we can increase, I mean, pressure or decrease it. Is that clear, children? So pressure can be increased or decreased just by changing the area. Okay, let us play a keep the weight, or I mean to say the force remains the constant, right? Is that clear, children? Is that clear? Now if I say, why, if we use the knife, we can easily cut the what, vegetables, right? Just because knife has very sharp area, right? Area is very less, area of contact is very less. Since area is very less, even though by applying the less amount of force, the amount of pressure it can generate is very high. Is that clear? And that is why the knife can cut the things easily. And this is, remember, I at the beginning of the way to increase and decrease, I said, can we cut the vegetable with the hand of our finger? No. Why? Because the surface area is larger. right? So larger the surface area, even though you apply the large amount of force, you will find there will be pressure generated is very less. Is that clear, children? Hope it is clear to all of you, children. Say yes or no. Now, children, let us write, okay, study the pressure in fluid. These are the pressure we understood, children, right? Let us write pressure in fluid. Okay, children, pressure in fluid. Please write down pressure in fluid. Again, this is very important, right, children? Clear? Let us demonstrate it with the with an experiment. Okay, children, with an experiment. Not, I mean, exactly, but you know this very easy. Children, just take a container, right? Okay, and you what you do, you fill it with water or any liquid, children. You fill it with any fill it, okay, with any liquid, or let us take, we have a very common liquid in every household, and that is what? Water. I fill it with the water. Clear, children? This is the water. Am I clear? Now just take the two holes, just make two holes, right? Let us make one hole here, right? This is one hole, right? Let us make one hole is here. Is that clear, children? Right? So you will find when you close, I mean, when you make two holes, obviously water will be get out of the container. Is that clear, children? If you see this water, if it comes to this direction, this distance, this will go to the longer one. Why, children? Because obviously the water applies pressure. So one thing we understood, children, that the pressure, the liquid apply pressure more when you go deeper down the liquid. Is that clear? We will discuss it after some time. Right now, for right now, time being, children, we understood that liquid also, I mean to say, let us talk about the fluid. I mean to say, children, fluid also exert pressure. What do you mean by fluid? Which can flow. So in this example, I mean to say, in this definition, both water and air fits. Right, children? So pressure, I mean to say, pressure exert by the liquid and also by the gases. Okay, we will talk about it after some time, right, children, about the gases. So what, children? This is what the pressure exerted by the liquid. Is that clear? So draw this diagram so that you see here the water pressure is larger. That is why water can travel the longer distance. Is that clear? Whereas here, since this is the surface of water, so let this is the height, I can say h1. This is the height, I can say h2. So obviously h2 is greater than h1. So we find since the water can travel the longer distance, so obviously let this point is A, this point is B. So obviously at B, I can say pressure generated by the fluid is obviously greater than the pressure generated at A. Okay, and it depends upon the height. Okay, so when you go deep inside water, the pressure goes on increasing. Is that clear, children? Right? So children, fluid, see about the fluid, if I say fluid, let us take water in this case, it can not only exert pressure, okay, in this direction, I mean to say in one particular direction. What, children? Liquid can exert pressure in all the direction, right, children? In all the possible direction, and also on the wall of container. Children, let me give one example. You might have experienced this example, children. See, if ever you have given you have gone to any swimming pool, right, or in any I mean to say river to take bath, right, children? You just place yourself inside the swimming pool, okay, and let us assume that water just touches our what? Water touches our what? That is this level, right? So that the water touches our neck, right? So children, whenever there is a flow of water, okay, you can feel the pressure of water on our neck. Is that clear, children? Right? Yes or no? It means what, children? That water exert, see, not only here, also here, this side, back side, this side, okay, all side of our neck we can feel the pressure, right, children? What it means, that pressure, I mean the body, I mean to say here, what is the body? Is liquid. The liquid, the fluid, I can say, okay, can exert pressure in all the direction, okay, and also on the wall of the container. So this water also exert pressure in this wall, in this wall, in this wall as well, right, children? So this is all about the pressure, I mean exert by the liquid. Children, is it understood? If you are understand, children, please, children, write down, yes sir, we are understanding. Please take your copy, make your notes, because your involvement is very important. I can provide you the notes, children, there will be no issue, but if I provide the notes to children, you will not get the worth of that note. Rather, what you do, try to prepare it from yourself using variety of pen, okay, so that the notes looks good, and when you make it, na children, in the similar process you learn it, right? And once you see writing the notes in your own handwriting, trust me children, once you complete the chapter, it will take hardly on half an hour or maybe 20 minutes for you guys to revive the entire chapter very quickly. That is the power of making the notes in our own handwriting by involving ourselves, right? We have to involve ourselves in the teaching learning process. Am I clear to everybody? Say yes or no. So now children, okay, we have demonstrated this. Now let us talk about what is the pressure exerted by the liquid. Okay, so come back children, please write down pressure exerted by a liquid column. Okay children, please write down pressure exerted by liquid column. Okay children, pressure exerted by the liquid column, we will prove it. Okay, what is the amount of pressure it exert? It means what children? Liquid exert. So let us take a container children. This is what a container. Okay, let us take the larger container. Okay, right children, hope you are understanding children, hope you are getting clear. Let us take, this is what a container we have taken, right? Okay, this is fill it, let us fill it with water. Okay children, I have just filled it with water. Okay, now do one thing children, take any container in this manner inside it. Okay children, right? Clear, right children? Low, this is a cylindrical shape children. I can take, you can take any shape, no issue, right? This is the cylindrical shape. Is that clear children? Let us place the water until the surface. Okay, let us place water. This is the water. Okay children, so you can see children here the height is how much? Let us assume the height of cylinder is h, right? So here you can see this height is h, right? And fill it with water. Please draw the diagram children simultaneously with me. Is that clear? Draw the diagram simultaneously with me. Let us name it, right? This is P, this is Q, this is R, this one is S. So PQRS is a cylinder. I place it inside the water where the surface of the cylinder and water is on the same level. Okay, both the cylinder and the water is in the same level. We want to find children what is the pressure it developed, right children? Is that clear? So you can see children here the area is A and here also area is A, because both are of the same area, right children? Is that clear? Say yes or no. Okay, so children, we have to find what is the pressure. So children, let us find first of all what is the thrust exerted by this PQ. What is the thrust children? Okay, so if I find what is thrust, thrust is nothing but mass, I mean weight of the body, right children? So thrust exerted by this body is m into g, its mass and acceleration due to gravity. Okay children, now children, we know that mass by volume is nothing but the density. Clear, right? So what is mass children? I can find V into rho, right? So multiply here, so thrust become what children? V, in place of mass replace V rho, that is V into rho into G, right children? So we know that area is meter square, right children? Length into breadth is meter square. Volume is equal to length into breadth into height, that is equal to meter cube. I can write here length into breadth, which is equal to meter square, right? So let us convert this volume into area into length, right? So I will write area. What is area children? PQ area. Is that clear? So area into what is height. Here length is what? Height. Okay, that is what the volume children. See children, we see, let us assume this is a cylinder, right? Its shape is cylinder. So this is what the area, pi r square I can say, right? This is area. You guys knows about the cylinder. You have in mathematics volume surface area. Don't worry children, gradually I will also upload the video of mathematics and chemistry, okay, for you, right children? So this is what the area I can say, right? This is what the area, okay, base area, multiply with height, that will give you the volume. Volume means the amount of space an object, okay, is taking, right children? So A in area and this one is height. Clear? So area into height into acceleration due to gravity. Is that clear children? That I will see, that will I will write volume and then into rho. Is that clear, children? So this is thrust. Now you divide area. So thrust by area is what, children? Nothing but the pressure. What is pressure? At the beginning we say it is nothing but the ratio of thrust per area. So which is good, H rho G. Is that clear, children? Clear? So pressure of liquid is nothing but H rho G. This is the amount of pressure a liquid exert, right? Is that clear, children? P equal to H rho G. Clear? Please write down this. Okay, right? Video ko pause karo and then please write it down. Right, children? Is it understood, children? Right? Yes or no? Very good. I know you all guys are champion girls also. Right, you all people are champion. Please, children, focus and please write down your notes. Every time I said what, children, that build it right and build it once. If you are building it once and rightly, trust me, every time you will have the benefit of that. You see, building it right and building with a very focused way. Is that clear, children? Now, children, you see, we'll discuss about what is the total pressure exerted at any depth. Okay, children, so we know that there will be a pressure of atmosphere which is also fluid. Yes or no, children? That P equal to H rho G. It's not only the water only exerting, right? This is the pressure which is exerted by the fluid. Okay, so what I mean to say, children, let us assume it. Okay, here is the a container filled with water. So on the surface of water, you will have what, children? Atmospheric pressure. Let this is PA, and this is the point. For example, capital A, which is nothing but H height from the surface of the water. So what is the pressure at A, children? It is nothing but the atmospheric pressure, that is PA, plus pressure due to this height, or I can say height of the water column. I already explained what do you mean by column, why we are calling it column, just because it is vertically standing. Is that clear? So H rho G, we know it very well. So this is what the pressure at any point A, nothing but the atmospheric pressure plus the pressure due to height of the water column or liquid column, we can say better. Is that clear, children? So if I'll ask you, tell me the factor on which the liquid pressure depends upon. Very easy, children. What are the factors? So P equal to H rho G. So first of all, P is directly proportional to height. Okay, P is directly proportional to density. Right, children? So height and density on which I can say also gravity. When you, how gravity changes, children? When you are going from one planet to another, right? Since as we have discussed in gravitational, remember, children, what was the case when we were discussing about the, when we take the body from earth to what, moon? So gravity is reduced to 1/6 times that of the earth in the moon. That is why in moon the gravity is less. How much time? 1/6 time. What is the value? 1.6 meter per second square, and we have studied this very well in the gravitation chapter. Is that clear, children? Is that clear? Right? So these are the, you see, the point at which you can say the P is also directed to gravity. Okay, children, right? On which the pressure exerted by the fluid depends upon. Okay, children, so there are some point, children, on which the pressure does not depend, right? What are those points, children? First, the shape and size of the vessel. Children, remember, the pressure exerted by the liquid does not depends upon what is the shape and size of the vessel, or I can say container. Am I clear? Right? And second, children, the area on the surface on which it acts. Okay, so this is not depends upon the area on the surface on which it is acting, or it is act. Okay, children, so these are the point on which it does not depends. It means what, children? Pressure. Whose pressure? Atmosphere, I mean to say the liquid pressure does not depend on which shape and size of the vessel first, and second is what, children? That is area on which it acts. Clear, children? It does not depend, right? Next slide, children. Next slide, law of liquid pressure. Children, write down law of liquid pressure. This is again a very important thing, children, right? Laws of liquid pressure. You see, in the many of examination, this question is being asked. Write down the laws of what? Liquid pressure. Very, very, very important. Okay. So, children, let us talk about the law first, children. Since we know pressure is directly proportional to height. Okay. So, with increase in height, pressure increases. Is that clear, children? Right? First, when your height increases, pressure increases. So I can say, children, if you go deeper inside the well, or I can say any river, let us assume, children, already we have done the experiment by making two holes. Remember at the earlier I have explained you, right, children? So let's study about, let this point is A, this point is B, this is height at h1, this height is h2. So I can say, since h2 is greater than h1, I can say p2 is greater than p1. So what is the pressure at A, children? How can I write? So pressure at A is nothing but atmospheric pressure plus pressure due to h1. So h1 into rho into g, right? What is pressure at B? That is atmospheric pressure plus pressure due to h2, or height of the water column, that is h2, or liquid column, h2 into rho into g. Clear, children? So clearly, since here h2 is larger than h1, I can say pb is greater than, sorry, p2 is, or I can say, okay, pb, you can take here pb, right here pa, no issue. Since h2 is greater than h1, I can say pb is greater than pa. Am I clear to all of you? Say yes or no, children. So first of all, the first law, okay, when height, or I can say, in particularly in case of river, this is depth, children, not height. Okay, see, when you are moving above, you don't have water. So how does the water will exert pressure on you? When you go deeper down the water, that depth we are considering here is height. Okay, children, is that understood, right? So the first is depends upon what? That is height. Second, children, in a stationary liquid, pressure is same at all the point in horizontal plane. Okay, children, listen, children, okay, see what, very easy at the same time conceptual. Children, this is the container. Let us assume a plane. This is the plane I have taken. Let this plane is AB, and let this one, I can say, CD, a line, I can say, right? So if I say, let here I have point A, point x, here y, here z, here I can say p, here I can say q, here I can say r. Let us take three point, right, children? So if at all I have to find, see, AB is a plane, right? So these all, children, x, y, z, right? So this is y, okay, this is x. Clear? So this height h1, for example, this height is what? H2, right? So we can call first, pressure at x is equal to pressure at y is equal to pressure at z. Similarly, pressure at p is equal to pressure at q is equal to pressure at r. But pressure at p, q and r is obviously greater than pressure at x, y, z. Why? Because the height of the water column, I mean to say the liquid column, is more in case of p, q, r, and PQ, PP and PR than XYZ. Am I clear to all of you? Since there is a greater height at the CD, that's why pressure at PQR is greater than pressure at XYZ. But at the same time, the pressure at P, at Q, at R are the same. The pressure at P, X and Y and Z also same. But the pressure of P I is greater than the pressure at X. Pressure at Q greater than pressure at Y. Pressure at R is greater than the pressure at Z. Am I clear, children? Right, children? So this is the second law. First law was, children, when you increase the depth, I mean to say height, okay, the pressure exerted by the liquid increases. Second is, when you take any plane, okay, inside the water, at each point on that plane, the pressure remains the same. Is that clear, children? Right? Now, third case, children, third one, right? That, I mean, the liquid, in the liquid, okay, pressure exerted in all the direction, children, that you should remember. Okay, pressure exerted in all the direction and also on the walls of the container. This one is the, children, third one, right? Okay, then see, children, what happens, we know that, see, the pressure also depends upon the density, right? So let us assume, children, let us assume in one container we place some water, okay, some water. Let us write H2O, right, children? You know what is the chemical formula of water? Yes, everybody knows, right, children? That is H2O. If you don't know, please write down in the comment box. I will tell you, children. See, one thing, you have to be open, right? When you are open, I mean to say, you are not, you see fearing, or you don't have a fear for criticism, right, children? I don't care who think what, right, children? So what you do, you please write down your doubt, whatever, however the simple doubt it may be, right? See, children, this doubt, if you are writing, I will solve it, right? But if you are don't writing out of hesitation, then what will happen, children? See, at the time when the examination comes, your that doubt will remain the doubt itself. And when, for example, if that question or that doubt in came into the, if it comes into the examination, I mean to say the question paper, then you will lose the mark. Is that clear, children? So that is why don't hesitate to ask me the doubt, children. Is that clear? Right. This is the water, and in this other container, children, let us take some milk. Right, some milk. Right, so water and milk both are different liquid, children. Both have water has rho w as density, it has rho milk as density. Since both have different density, children, what I mean to say, just to explain you, children, let us take two different what liquid. Okay, in one we have taken water, in one we have taken milk. Am I clear to all of you? Children, what happens, what I mean to explain, let us take the two liquid of different densities. Okay, children, now at point A, here at point B, at the same height, I'm telling you, same height, same weight of the body, right? Is that clear? Pressure exerted by the milk will be greater than the pressure exerted by the water. Clear, children? Why? Because pressure is directly proportional to the densities. You see, P equal to H rho G. Is that clear? So larger the density, larger will be the pressure. Am I clear to all of you? Right? So this is how, children, liquid, two different container, two different liquid, okay, or same body, okay, children. So the liquid which have the larger density will apply the larger pressure as compared to the liquid which has lower density. Am I clear to each and every individual? Right, children? Very good. Okay, next, right, children, last one is a liquid seeks its own level, children. Right, see, we know that pressure does not depends upon the size of container, right? So if you put water in any container, the liquid will seek its own level, right? So these are the 5 laws of liquid pressure, right? Let us understood some consequences, right, children? Some consequences of liquid pressure. Okay, children, some consequences of liquid pressure. Or we know that what is pressure equal to P equal to H rho G. Okay, these questions are very common, children, right? But at the same time, you have to understand it very well, right? So first, children, okay, the pressure at certain depth in a sea water is more than at the same depth in the river water. Very easy, right, children? Now, for example, I have a sea here, children. See, not I have a sea, sorry. Let us assume this is a sea and this is the water. I mean, it's a river. Okay, children, this is the sea, this one is the river. Tell me which have larger density, children? Obviously sea will have larger density because of some impurities is added in the form of salt inside the water of the sea, right? So here density, children, density of sea water is rho s. Let this is rho r. So which one is larger? So density of sea is greater than density of river. Just before a couple of seconds I was explaining you that the greater the density, greater will be the pressure. Am I clear, children? So the sea water at the same height, let us assume this and this same height, okay, which will exert more pressure, sea water will exert the more pressure as compared to the river water. Am I clear to all of you? Say yes or no, children. Is that clear? You might have heard about the Dead Sea, children, right? Have you heard that? Dead Sea, Dead Sea, okay, it is a sea where the density of water is so high that you want, if you swim in that water, you will never see tum डूबोगे नहीं बच्चों. Is that clear? समझ में आया ना? Is that clear, children? Right? If you swim, okay, in the Dead Sea, okay, you will never, you see, डूबोगे नहीं तुम वहां पर. Am I clear? Right? Why? Because the density is very high. Clear, children? Right? Yes. Next question. Okay. Next is what, children? The wall of the dam is made thicker. Right, children? You might have seen the wall, right, of the dam. Have you seen a dam, children? This is a dam. Okay. Is that clear? Are yaar, yes or no? Right? Here is the water. Okay. Here is the water. Right, children? So if you see, this is the upper portion. This is the lower portion. Which one is wider? Obviously the lower portion is wider. Why, children? Because when you are going deep inside the water, we know P equal to H rho G. Higher the height, higher the pressure, right? So pressure goes on increasing. Okay, children? But if the pressure goes on increases and if the wall is what? Thin, I mean to say the narrow, obviously the wall will break. I mean to say the bridge will, or the dam will collapse, right? So that is why, children, here, for example, here the maximum pressure P, right, which is equal to force per area, because this is a pressure exerted by the liquid on the solid, right? This wall is is solid, right? So if we made the area larger, so even though the effect of pressure which will be larger at the depth, okay, will reduce, right? So here the pressure will be very less, okay, and the bridge, or I mean not bridge, the dam will not collapse. Is that clear, children? Right? So is this understood, children? Right? Next, children, if we talk about, okay, water supply tank. Okay, children, you might have seen in your house the water supply tank, or I mean to say the overhead tank, right? Is always kept on your what, children? Terrace of the building. Is that clear? So that you see, whenever you open the tap inside your kitchen or washroom, okay, the since the height is very large, so the pressure of water inside, okay, I mean anyway in your home, the tap inside the tap is larger. That is why we are keeping or placing the overhead tank on the what, on the terrace of our building, I mean so the top of the building. Is that clear? Right? So that height increases, then pressure increases, there will be larger pressure of water in the tap in the ground floor. Am I clear to all of you? Right? Next, children, see the diver. You see, you might have seen, know the diver, right? The divers, you wear the special shoes, right, when they are going for scuba diving. Have you heard the term called scuba diving, children? Right? If you have not heard, children, there is a movie called Zindagi Na Milegi Dobara, right? You might have seen it, right? But अब जाके देखना नहीं है, राइट? ये बहुत पुरानी मूवी है बच्चों. इज दैट क्लियर? लेट अस नॉट गो एंड वॉच इट, राइट? देख लेना, लेकिन अपने फ्री टाइम में अभी यहाँ पढ़ लेते हैं, राइट बच्चों? तो देखना वहां पर वो जो ऋतिक रोशन होता है, क्या होता है, वो जाते हैं समंदर के अंदर, राइट? एक स्पेशल सूट पहनते हैं बच्चों. इज दैट क्लियर? सो डाइवर्स हैव I mean design a special suit. Why? Because when you are going in deep inside the sea, the pressure due to the water column is goes on increasing. Why? Because the height increasing, I mean to say the depth increasing. Okay, children? So the if the pressure exert by the height of the sea, I mean to say the water column, if it exceeds the blood pressure, children, then body may burst. Is that clear? So a special suit is being designed so that the pressure in no way going to increase than the pressure of the blood. Is that clear, children? Right? And the last one, children, I can say what, size of air bubble, right, children? You see the size of gas bubble when they are moving up, right, children? See, this is the bubble, right? If it's moving up, you see the size grows, right? Why does this happen? Right? So children, see, when it is here, so here the water column is H, right? So depth is higher, so pressure is higher. So if pressure is higher, so obviously what, children, the drop is smaller. But when it goes up gradually, so pressure goes on reducing, right? Pressure reduces. Why? Because the height of liquid column reduces. For example, here this one height is what, H dash. So here H dash is less than H. Right, children? So pressure at H dash is lesser than the pressure at H. And we know Boyle's law, what, children? PV equal to constant, right? So B is inversely proportional to pressure. So when the body goes, I mean to say when the bubble goes up, right, what about the pressure? Goes on decreasing. So what about the volume? Goes on increasing. Temperature remain constant, children. That you should remember. Temperature equal to constant here, right? So at constant temperature, PV equal to constant, I mean to say V is inversely proportional to P. Am I clear, children? Everybody say yes or no, right? So that is why the size of bubble grows on increasing because the volume increases, right? So these are certain consequences, children, right? Now let us understand, okay, what do you mean by Pascal's law? Okay, children, so name the heading. Okay, transmission of pressure. Right down, children. Transmission of pressure. Okay, children, transmission of pressure, right, children? In a liquid, or I can say Pascal's law. Okay, children, what is law? Which law? Pascal's law. Okay, children, very important. Okay, and very easy, children, we can understood it with the help of what? Experiment. Let us conduct an experiment, not I mean to say physically. Let us understand an experiment on the whiteboard itself, right, children? First of all, let us understand what is the Pascal law. Pascal law says, children, when you apply the pressure will transmit without any loss, okay, in all the direction equally. Let us understood it, children. See, let us make a container in this manner, right? Okay, right, I have made a container in this manner. Is that clear, children? Right? right? So let us place a what, children? Piston, right? This is what the piston is. That clear, children? Right? And this one is filled with water. Clear, children? Can you imagine it? Right? Just no derivation required, children. Just understanding of Pascal law. What does it all about? Right, children? What does it all about? I place water inside this container which is being connected with a what, children? This one is what? Piston. Right, children? Okay, now what I did, I just make small holes here, here as many. Okay, doesn't matter, children. Right? Now when you are applying force on the piston, right, this piston obviously will come down, right? Right, children? Come down. So when it will come down, now since there is the hole on the surface, so obviously water will what, get inside, I mean get from inside, right? Is that clear, children? Is that clear, children? Right? So what is the question? When you apply the thrust, I mean to say the force on this area, so thrust per area is, it generate pressure. So when you apply the pressure, this piston will come down and it apply the force on the liquid, right? And this pressure, I mean to say, transmit in all the direction equally. I mean to say, here the pressure, let this is P1, this is P2, this is P3, right? This one is P4. So I found P1 is equal to P2 is equal to P3 is equal to P4. Is that clear? Yes or no? Is that clear? Yes, brigadier, right? Okay, right, children? So this is the pressure P1, 2, 3, 4, all are equal. This is all about the Pascal's law. Right, children? So children, you please draw this diagram so that you will understand better, right? So please draw this diagram, and this is all about the Pascal's law. Okay, children? Right? Now on the last portion of this chapter, what is that, children? Application of Pascal law. Children, what is that? Application of Pascal law. Okay, how does the Pascal law we apply? Okay, so the application of Pascal law means hydraulic machine. So we will apply the Pascal law in hydraulic machine. So children, very easy. Children, don't worry, huh? Very easy. I mean, just don't get tense. Okay, what this hydraulic machine is all about? See, we have to study hydraulic machine. No, 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 not at all. Not at all. Right, children? Okay, let us connect this to by means of a pipe. Is that clear? Right, children? Just do one thing, right? This container is of larger area, this container is of smaller area, right? So here, okay, what do we do, children? Just we place a piston, let us assume, and place what, some weight here, some weight. Okay, these are nothing but the liquid, right? These are nothing but the liquid. Is that clear? Yes or no? This is any weight, okay, whose weight is m into g, right? This area I can say a1. Okay, right, children? Right? Okay, right. Here the area I can say, is what, children? Here is a2, right? Clear, children? Okay, so now the thrust you apply here in the first cases, I can say T1, or there it was T2, right? So let this, children, the water, obviously when you place water, I mean to say any weight on this area, so there will be a pressure downward, right, children? And whenever there is a pressure downward, so obviously this pressure will try to what transmit from container A to container B. Let this is container 1, this one is container 2. It will transfer from A1 to A2. Is that clear, children? Please draw the diagram, right? Please draw the diagram. Okay, children, I can select this is piston A, PA, not pressure, children, huh? Not pressure. This is piston, huh? Piston A. This one is piston, yes, children, piston B, area A2. Okay, so here the force will be F2, upward, right? Here the force weight will be vertically downward, right, children? So two pistons, right? Clear, right, children? Okay, right? And the liquids are same, children. Remember, huh? This liquid and both liquid, these are both what? Liquids. Clear? Okay, these are two what, children? Liquids. Okay, so what the principle of hydraulic machine says, children? Let us assume this container is P and this container is what? Q. Clear? So hydraulic machine principle says that a small force applied on a smaller piston is transmitted to produce a large force on the bigger piston. Okay, so if we apply the small force here, which is weight, on the smaller portion, it will transmit to the large piston with the greater force, right, children? Or I can say the pressure here generated when you apply the small piston P1, here is P2. Okay, so what is the application? Where is the application, children? You apply the force here, right? There's the smaller piston, there's the larger piston. The smaller piston, smaller force will generate the larger force on the larger piston, right? So here force will be larger, right? And P1, here the pressure generated is P1, here is P2. So we find that P1 is equal to P2, right, children? So the pressure will transmit here from piston A to, I'm going to say from container A to container B, or I can say from piston A to piston B. The pressure will transmit it. Am I clear, children? Easily. Okay. So the pressure at P1 will be equal to pressure at P2. Remember, children, one thing: the force you applied, the smaller force you applied at the smaller piston, right? This will generate the larger force, okay, on the larger piston. So children, what is P1 is equal to? Nothing but force per area, F1 by A1. What is P2 is equal to? F2 by A2. So you divide A2 here, multiply A1 there. So this F1 by F2 is equal to A1 by A2, right? Children, this is the, this is one formula based upon which we will solve the question regarding the what? The hydraulic machine. Is that clear, children? Clear. So you will find, obviously F2 is greater, right? F1 is smaller, right? But the pressure or area is, you see, children, area is here is lesser and area is here larger. Children, just imagine here F1 by A1. Okay, here you can say the force is smaller, area also smaller, right? Here the force is larger, area is also what, children? Larger, so that the ratio becomes the same. Is that clear, children? If I say multiplication of two number A, B equal to constant, see, if at all equal to A, B constant, it means what? A1 B1 is equal to A2 B2, right? So if this has to be happen, one thing you should remember: if A increases, B has to decrease, then only this will be holds good. For example, if I say let let here only, let us understand, let A1 is equal to 10 or B1 is equal to 5. So what is A1 into B1, which is going to be how much, children? That is 50. So A2 B2 also must be 50. Is that clear? Let us decrease A1. If area decreases, let A becomes 5. So B has to be 10, right? Then only it will be 50. So when you decrease A, area B has to be increased. Is that clear, children? But in ratio, you see, if F1 decrease, A1 decrease, so there is a decrease. That is same as, you see, F2 increase, A2 increase in the same amount. Okay, children? Force increases, area also increases, so that the ratio remains the same. So pressure will be transmitted equally from piston A, from container A to container B. Is that clear, children? So this is what F1 by F2 equal to A1 by A2, that you should remember. Please draw this diagram, right? Derivation is not required, children. Is that clear? Is that clear, children? So the last portion, children, in this, okay, I can say examples of hydraulic machines, right, children? So examples of hydraulic machines, children, it is not in the syllabus right now. Okay, so let us not read it further. Okay, children, so till now I think, children, you got all the concept very clearly, right? In the next video we are going to solve the question one by one, including all the example and exercise question one by one. Okay, children, we will solve it. Clear, children? So hope, children, you got all the concept rightly, clearly. If you got all the concept, children, if you're happy, please share my channel, like it, subscribe it, and share among your friends, right, children? We are also making the video of chemistry and mathematics very soon. We are making the video of class 9, class 10 physics, chemistry, math, class 11, 12 only physics. Okay, children, share this channel among your friends, and if you like it, please subscribe the bell icon, so that you will get all the notification update about this channel. Is that clear, children? Children, thank you so much and God bless you.